All right, so this section is on rational functions. And one thing about what a rational function is, a rational function is when you basically have a fraction, right? And you have variables in the numerator and in the denominator. So it's the quotient of two polynomial functions. So you've got a fraction and you've got a function on top and a function on the bottom. All right. So how do you figure out what is the domain of a rational function? Well, the domain of a rational function is all the numbers that basically when you plug them into the function give you an actual value. What does that mean? That means if you take all the numbers in the world and if you exclude all the numbers that make the denominator 0, that's the domain. All right, so basically you have to exclude all values for which the denominator is 0. In other words, the denominator can never equal 0. Well, you just have to find all the numbers that make the denominator 0, okay, and all the numbers except for that is the domain, okay? We'll go through how to find the numbers. Okay, so one thing about rational functions is many of them have asymptotes. All right, so let's talk about asymptotes for a minute. Asymptotes are lines, either vertical or horizontal. And these are lines that the graph comes exceedingly close to, but never touches. Okay? Now, we've got vertical asymptotes, as I mentioned. And here is an example of a vertical asymptote. The graph is never allowed to touch the vertical asymptote. That means here the vertical asymptote is at x equals -2, right? That means when x equals -2, that function can never exist, all right? Now, look at the function for that particular graph, right? It's 5 over x plus 2 squared. What happens if that x value was -2? Then it would be 5 over what? 5 over 0 squared, which is 5 over 0. And can you ever divide a number by 0? No. Never. It's undefined. Okay, and that's how you get a vertical asymptote. You get a vertical asymptote at the points where the denominator is 0. Okay? Now, what about a horizontal asymptote? I feel like horizontal asymptotes are horribly misunderstood. Okay? A horizontal asymptote, again, it's a line which the graph comes exceedingly close to but never touches. However, unlike vertical asymptotes, horizontal asymptotes only come into effect at the infinity. So when x equals like 1,000,000 or when x equals -1,000,000, all right? So for example, it's very possible that you have a graph that looks like this. Here's the x-axis, here's the y-axis. Now suppose there is a horizontal asymptote there. It's very possible that you have a graph which crosses the x-axis 1,000,000 times, and then in the end, it follows the asymptote, okay? So a graph can cross the horizontal asymptote as many times as it likes. It's only in the very ends that it starts to level off with the asymptote. Does that make sense? Lots of students get confused at this point, but just make sure that it is okay. All right, so let's get down to business. How do you find the vertical asymptote? Okay, basically, you simplify the function, and then you find the zeros of the denominator, and those are your vertical asymptotes. That's all. Okay? All right. How do you find the horizontal asymptotes? Okay. What you do is you divide the term with the highest, this should say degree, with the highest degree. in the denominator by the term with the highest degree in the numerator. Okay? So now there are a few cases. Let's look at this one. Suppose the numerator has a lower degree. Okay? So look at this one. Look at the numerator. What's the term with the highest exponent?
2.
The exponent is 2, but what's the whole term?
3x.
3x squared, right? 3x squared over, in the denominator, what's the term with the highest degree? 2x cubed. Okay? So this is one where the numerator has a lower degree, right? The top one has a lower exponent. Okay, so what happens this? What happens when you simplify this? You have the 2x's here go away, and then you have how many left on the bottom? You had x squared on top and x cubed on the bottom. 2 cancels with 2 here. You have 1 left on the bottom, right? Okay, so now, whenever you have an x left on the bottom, you say the asymptote is y equals 0. The asymptote, the horizontal asymptote is y equals 0.
Where did the center of -4?
Well, you ignore those when you're looking at asymptotes.
So you're only the ones that have.
The highest degrees. The highest degrees. Yes. If there is an x in the denominator but not on top, then it's y equals 0. Okay, now, what if the numerator and the denominator have the same degree? All right, like this one. So in the numerator, what's the term with the highest exponent? -5x cubed. And on the bottom, 2x cubed. What cancels here? All the x's, right? X cubed. So what am I left with? -5 over 2. So the horizontal asymptote is y equals -5 over 2.
But I thought it was always the other 0. Oh, so if you end with an x on the bottom,
Yes.
it's 0.
Yes.
But then if you don't
If-
have an x, it's just 0.
Right. Okay?
When it was 0
Mm-hmm.
times 2 is 0, and you cannot divide.
Mm-hmm.
You have to write horizontal.
Yes, you have to write horizontal, and it has to be y equals blah, blah, blah. I'll get into the specifics in a little bit. Now, if the numerator has a higher degree, there is no horizontal asymptote. We'll look into that later on in this lesson. All right? Okay. So let's put it all together. Let's find the domain, the vertical asymptote, and the horizontal asymptote. Okay? All right, so for the domain, okay, ask yourself, where is the denominator equal to 0? So let's take the denominator, x squared minus 1, and set it equal to 0. Okay. Now I need to solve this. Is there any way to factor this? Right, so it's x minus 1, x plus 1. Now, when I set each one equal to 0, here I get x equals 1. And x equals -1.
But isn't that the same thing as doing
Yes, in this case it turns out to be the same, but most of the time we're going to have to factor. So I just like to show you the factoring. Okay, so when x is 1 or when x is -1, what does that make the denominator? 0, right? That means those are the points that x cannot exist. Yes? If x is -1 or +1, the denominator is 0. So x cannot be either 1 or -1. So I say the domain is, okay, it's all the numbers except for what and what? 1 and negative 1. So how do you say all real numbers in math? You could either say, huh? Have you guys seen this before? No? Have you seen this before? My eraser doesn't work. Yes? Okay, so that means all the real numbers in the world minus which ones don't work? 1 and negative 1. Okay, so that's the domain. All right, so let's recap. What I did here is found the numbers where the denominator would be 0. And I say, okay, I can't have the denominator equal 0, so I can't have my x's equal to 1 or minus 1. So what can I have my x's equal to? Well, anything but 1 or minus 1. So it's all real numbers minus 1 and minus 1. All right, vertical asymptote. Right? How do we find vertical asymptote? What did it say on top? You simplify and then find the zeros of the denominator. So for most cases, this is going to be the same process as your domain. So look at the function. It's already simplified. I can't simplify that any further. So what I do is the same exact thing. I set my denominator equal to 0. Okay? And it's the same process, so you really don't have to repeat it. When I solve this, what do I get for x? Negative 1 and positive 1. So my vertical asymptotes are x equals negative 1, x equals positive 1. Okay. In order to get full credit, it's not enough to just say 1 and minus 1. You have to say x equals 1, x equals negative 1. Why? Because what's the asymptote? What does it look like? It's a line. So you have to give an equation. All lines have equations. If you just say 1, that's a point. You have to say x equals to get a line.
So this one has 2 lines?
2 asymptotes, yes.
So that's possible?
Yes. Okay, now for the horizontal asymptote. How did we find horizontal asymptote? Right. So what we go back to the original function. You take the term with the highest degree from the top, the term with the highest degree from the bottom. In the numerator, what's the term with the highest exponent? There's just x, so it's just x over what? X squared. So what happens here when you simplify? What cancels? Right? You get 1 over x. And what happens when you end with 1x? Y equals 0. Okay? So there we go. We just found asymptote. When there is only an x left in the bottom, or, right, it's or like 3x or 5x, then you just say y equals 0.
So what if there's a 0 on the bottom? Same thing.
There will never be a 0 on the bottom.
How did you? Why is 1 0? Every time x.
Every time you end with an x in the denominator, an x to the power of 1, the asymptote is y equals 0. Okay. So for part B, we're going to do the same thing. All right. So for domain, what do we do for domain?
0.
You say it. What is it?
The denominator.
Set the denominator equal to 0. So go ahead and set the denominator equal to 0 and let's solve. Well, when you have an x squared plus something, it can't be factored. So let's see. So 2x squared equals negative 1. Divide by 2. That's the denominator. So x squared is negative 1/2. What do I do now? So x is plus or minus the square root of negative 1 over the square root of 2, right? What's the square root of negative 1?
I.
I. And is that a real number? No. That means there are no real numbers where this denominator is 0. Okay? So there is nothing that's going to give us an issue. There is no way to make the denominator 0. That means we have no problem points. That means every number in the universe works for this. So the domain is just going to be all real numbers. Right, because when we tried to get a value for which the denominator is 0, we couldn't. We couldn't find any number to make the denominator 0. That means there is no number for which we're going to have an issue. That means all numbers are fine. I is an imaginary number. Whenever you have the square root of a negative number, that gives you an I. So if you remember back to your algebra days, because I squared is -1, so the square root of -1 is I. All right?
So there's an I at the top of the numerator, then it's all the numbers. The numerator, the I is on the numerator.
Right, so when you try to solve it for 0 and you get an imaginary number, the domain is all real numbers. Because there is no way to make, yes, there is no way to make the denominator 0. Now, technically, when you're solving for a domain, you're also solving for x-intercepts. I'm sorry. When you're solving for a domain, you're also solving for vertical asymptotes. So when you can't get any x values here, that means there are no vertical asymptotes either. When the domain is all reals, there are no vertical asymptotes. Okay? There is no function that has a domain of all reals and it has vertical asymptotes. That does not happen. Horizontal asymptotes, whole other situation. So now let's do the horizontal one. All right. Okay. What do we do for the horizontal one? Uh-huh. Right, so 4x squared over 2x squared gives you what? 2. So the asymptote is what? Y equals 2. Okay, just 2 will not be full credit. All right? Okay, so there's really no use to knowing what the asymptotes and the domain of a function is and not graph it, right? It's like, we might as well. So let's, okay? Okay. So look at that function, and never in your life would you have probably imagined that you could just graph that with no use of a calculator. So just what I know. So this is like so much more gratifying to do it all on your own. I mean, it's amazing. So watch. Let's find the domain. What am I going to set equal to 0? X squared minus 4 is equal to 0. Does that factor? Yeah, how does it factor?
Plus or minus 2.
If it's x squared plus a number, you can't factor. But if it's x squared minus a number like 4, which is a perfect square, then you can factor in this beautiful method. Okay? It's x and x, yeah. Most of the time, we're going to have to like actually factor. So I want you, it would, plus or minus.
But why the, yeah, because you just add 4 and then just.
Okay, right. Okay, so the square root of 4 is 2, but here 1 gets a plus, 1 gets a minus. Right, okay, so whether you solve this by factoring or by the square root system, you get the same answer.
Always plus or minus.
So x equals -2, x equals +2, right? So what's the domain then? Uh-huh. All real numbers minus, yeah. And you could either do 2 minus 2 like this. You could also say all real numbers minus plus or minus 2. It's really the same. Okay? All right. In doing this, we've already solved for the vertical asymptotes. Okay? So you don't have to do it again. So you just say, okay, my vertical asymptotes are x equals 2, x equals negative 2, or shorthand form, you could write it as x equals plus or minus 2. That works as well. Now we're going to plot the asymptotes. So x equals 2 and x equals minus 2 both have asymptotes. We do dashed lines. And yeah, if you do it exactly on the grid lines, it might not show. So just do it like a hair to the side. Okay? All right, what about horizontal asymptotes? Right, x over x squared, and that gives you 1 over x. So what's the horizontal asymptote? Y equals 0, because we ended with an x in the denominator. Okay? Okay. Well, almost. Now we're going to graph this. Let's pick a few points. My favorite point to pick is x equals 0, right? When x equals 0, how much is this? You plug it into this function, so you get 0 plus 1 over 0 minus 4, negative 1 over 4. So when x equals 0, y is negative 1 over 4. Okay. How about when x equals minus 1? You get minus 1 plus 1. Well, I'm plotting them. Right, you see the green dot here? So what I'm doing with x equals 0, I take x equals 0 and I plug it into here to see what y equals. And then when x is 0, y is negative 1 over 4, so it's right there. And then when x is negative 1, what's y? It's 0 over negative 3. What's 0 divided by a number? If you have 0 pieces of chocolate and you have to divide it between 3 people, everybody gets 0, so it's 0. So when x is negative 1, y is 0. Okay? Now, do you see? Okay, I only have 2 points, but I can already see a trend. I can see a trend that, you know what? This is going to go downwards from left to right. Okay? I also know that it's got to follow the vertical asymptotes on the left and the right. And I know that this is going to go downwards, so it means it's just going to keep going downwards and downwards and downwards. Because remember, the graph can never cross the vertical asymptote. So it's going to keep going downward like this. Well, the reason why I know that, okay, so most of the time it's going to be like this, okay? But you're right. So to test it, you know what? Let's put in one more point. You're right. That is a good question. So let's do x equals 1 as well. When x is 1, it's 1 plus 1 over 1 minus 4. How much is that? It's 2 over negative 3, right? Which is like negative 0.67, so it's somewhere there. Okay, so now I know that it is going down for sure. And on this side, it's got to keep going up like that, right? Now, is everybody okay with this? I just want to do one more thing before I let you go. Now look, this is like those old Pac-Man games or the old Atari games. If a graph exits the screen next to the asymptote on the top, then it's got to re-enter the screen from the bottom, from the other side, here. Okay? Here. So then it comes up, and it's got to follow the asymptote. Okay? Because it's got to follow the asymptote. It's always going to be like this. It does the same thing on the other side. Watch. Watch. It comes down here. Okay? Then it must re-enter here, and there is a vertical asymptote here, so it's got to follow the asymptote in the end. It's got to live the rest of its life following the asymptote. It's bound to the asymptote. Okay?